Hello my dear friends, welcome to my channel Math and Fun with Samson Pinto, and today I'm going to discuss in this video I'm going to discuss with you a few differentiation formulas. Okay, differentiation formulae or some formula. Okay, and it is very important that you kind of memorize these formulas because uh, it will make your life whole lot easier. So let us discuss what is the first formula here. What is d by dx of x to the power of n? It is nothing but n into x to the power of n minus 1. Now if you want to know how to derive this formula, you can go back and apply first principle method here that we had done in our previous video. I think it was the video number 3, where you apply it as x to the power of where you express it as limit del h tends to 0 x plus h to the power of n minus x by n divided by h. You can apply this first principle formulas and derive this formula. If you want to do it, it is a good exercise to do it. I will suggest, if you're interested, you can do it. Okay, so I'm not going to deal with the derivations of these formulas because I've already done it one formula, and I'm just going to tell you how to do the other, how to just do the formulas, how to remember the formulas, or how to just what are the formulas. So d by dx of k is nothing but 0, where k is a constant. It is not dependent on any of the functions, especially since you are differentiating with respect to x. It is not dependent on x. For example, the constant k may be 2 or constant k may be a, okay, which is not dependent on x. Okay, and here also you should remember one of the important rules which I have not put because I wanted to discuss this first. If you have d by dx of k into a function f of x, okay, then it is nothing but k into d by dx of f of x. So here in this case this doesn't become 0, constant is unaltered and it comes out, and you have to only differentiate the function. Alright, similarly differentiation of log x is 1 by x. Now when I say log x, for our future references or all other references, log x, this is nothing but natural logarithm and the base is e. Okay, the base is e, and I normally, when I write log x, it means the base is e. Okay, and if I specify log 10x, then it means the base is 10. Normally that is the practice I follow, but in all the books, natural logarithms, that is log e of x, is normally represented as ln x. Okay, that is nothing but natural logarithms. It is represented as ln x, but I represent it as just log x because it is much simpler to do it that way. Okay, and d by dx of a power x is nothing but a power x log a. Okay, where here again the base is e. Okay, and differentiation of e power x is nothing but e power x. So this doesn't change. Okay, proceeding further, now we are going to get into some of the trigonometric functions. Okay, some of the trigonometric functions, and then I am going to discuss some rules with you. So differentiation of sin x, as you have already seen, is nothing but cos x. Okay, it is nothing but I'm sorry, something weird happened. It is nothing but cos x. Okay, it is nothing but cos x, and differentiation of cos x is negative of sine x, negative of sine x. Okay, and differentiation of tan x is secant square x. Okay, or sometimes also written as secant x whole square. Okay, and please note that this secant square x or secant x whole square is not equal to secant x square. I have seen many of my students doing this mistake. It is not equal. Okay, secant square x is very different from secant of x square. Okay, probably when we solve one of these problems in the future, I will come to this why it is different, but they are completely different. Okay, and also in all these functions, x is in radians. Okay, you in most of the books you might find it as theta, or you might find it as alpha, beta, but I just prefer to write it as x or theta. Okay, and differentiation of cot x. Cot x is essentially nothing but cotangent. Okay, differentiation of cotangent x, okay, is nothing but minus of cosecant square x. Cosecant square x is nothing but cosecant square x. Cosecant square x. Okay, and again same applies here too. It is not equal to that, and differentiation of cosecant x is minus cosecant x cot x. Okay, minus cosecant x cot x, and differentiation of secant x is nothing but secant x tan x. Okay, it is very important that you remember these formulas. These are some basic formulas, and further we will be dealing with inverse functions, which will probably come later. Sine inverse, tan inverse, sine inverse of x, tan inverse of x. We will come to that boat when we are going to solve those problems. But basically there are some of the rules you should follow while differentiating, and those I'm going to discuss here. Okay, and maybe a very few problems, maybe 3 or 4 problems on how to apply 1 or 2 rules, not all the rules, maybe just 1 or 2 rules. Okay, so let us say you have from now I am going to just for easier understanding, I'm just going to express f of x as u and g of x as v. So for these rules you need two functions, f of x as u and g of x as v. So d by dx of u plus or minus d by dx of v is essentially nothing but du by dx plus dv by dx. Okay, also please remember that here u is a function of x. U is dependent on x. Also v is dependent on x. Okay, this rule is called as sum rule. Okay, next we come to product rule, which is d by dx of uv, which is nothing but u dv by dx plus v du by dx. Okay, which means that first function into differentiation of second function. Okay, then second function into differentiation of first function. Even if you reverse this, it is fine. You can do it like v du by dx, okay, plus u dv by dx. This is fine. Okay, okay, and this is called as product rule, right? So moving on, we'll come to quotient rule, and quotient rule is nothing but, okay, it is denominator is v square, okay, square of the function v du by dx minus u dv by dx, okay, v du by dx minus u dv by dx. And please note that this formula cannot be changed as v square or v square u dv by dx minus v du by dx. This is not equal to this, okay, and here it is always the term that is in the denominator, okay. My students often get confused with this stuff, so I normally tell them to avoid the quotient rule by a special principle, okay, by a special method. I tell them express u as one function and express 1 by v is essentially some other function uv, let us say take it as w, and then use the product rule, okay, u dw by dx plus w du by dx, where essentially w is nothing but 1 by v, okay. I'm converting the quotient rule into the product rule, okay. If you get confused with the quotient rule, you can still do this. There are a lot of ways you can tackle the quotient rule and just use the product rule. So done, this is done, right? Then moving on, okay, some simple 4 or 5 problems I'm going to show you on how to do differentiation here. What is the answer here? Now here we are going to use the differentiation of x power n, and that is nothing but n x n minus 1, okay. So this becomes 6 into, okay, let me see if I can change the color of the ink. Let me use green here, okay. So 6 into 3x square, okay, minus 9 into x to the power of 1. So here x to the power of 1, that is 1 into x to the power of 0 plus, here it is, there is no x, it means it is differentiation of a constant which is nothing but 0. So this whole term becomes 6 3s are 18x square minus 9, okay. X to the power of 0 is essentially nothing but 1, okay. Another similar example, this time I'm going to directly solve it, okay. I suggest you guys to do it slowly first, okay. So once you do it slowly, then you will get the gist of it, okay. So it is nothing but 8, okay, 8 4 2s are 8t cube minus 20t plus 30. That is what the answer you will get. And please verify this answer, it is correct, but verify this answer slowly by using this principle. One by one you use x power n formula, okay. Now here, coming to this problem, I am going to show you this problem in 2 ways, okay. Let me just kind of copy this problem. Ting. Let me just kind of copy this problem, okay, and let me place it somewhere else. Let me place it here, okay. Let me place it here and let me say paste, okay. So I'm going to solve this problem here in 2 ways, right? I'm going to solve this problem here in 2 ways. The first way is just by multiplying inside. Y of x is equal to, I'm going to multiply x to both these terms, okay. So that will give me 3x cube minus 9x. And when I differentiate this dy by dx, I will get it as 3 into 3 to the power square x square, 3 into 3x square minus 9. That is nothing but 3 3s are 9x square minus 9, or it is nothing but 9x square minus 1. Okay, you can do this. Next, in order to show you the product rule, I'm also going to solve this using product rule, where I take u as x and v as 3x square minus 9. Okay, and when I do this, I get du. Okay, so when I take u as x, let me first write down the formula for you. Dy by dx is nothing but u dv by dx plus v du by dx. Let us just solve using this method now. Dy by dx is nothing but u x times differentiation of this function. Okay, now dv by dx, what is it? It is nothing but 3 2s are 6, right? 3 2s are 6 x, okay, 6x minus differentiation of constant is 0. Okay, so you will only get 6x here, right? You'll only get sorry, am I right? I think I'm right. Yeah, you'll get just 6x here. Okay, dv by dx is 6x. Okay, and v, I'll write down v as it is du by dx. That is nothing but 1. Differentiation of x is nothing but x to the power of 1. That is nothing but 1 x to the power of 1 minus 1, that is 1 into x to the power of 0, and that is 1. Okay, so just differentiation of x is 1. So let us substitute that in the formula. U is x and dv by dx is 6x plus v is nothing but 3x square minus 9 and du by dx, that is nothing but 1. Then what I am going to do is I'm going to simplify this and write it as 6x square plus 3x square minus 9, and that is 9x square minus 9, and that is nothing but dy by dx is equal to 9 into dy by dx is equal to 9 into x square minus 1. So either way you can do it. Okay, either way, I just wanted to show you that this problem, either way you can do it. Okay, so that is the reason why I kind of chose this formula. All right, and chose this problem. And next, proceeding to the next problem, differentiation of phi e power x. It is nothing but same as writing d by dx of k into a function, where k is phi and the function is e power x. And I have told you it is nothing but phi times d by dx of the function, right? So this will give me an answer of phi times d by dx of e power x, that is nothing but 5 e power x. Okay, my last problem is d by dx of 2 power x. Okay, 2 power x. Okay, and 2 power x is essentially nothing but a power x. I told you a may be any number. Okay, a may be any number. This is nothing but directly 2 power x log 2. Okay, 2 power x log 2. Now what I am going to do is I am going to show you one more problem which I was thinking of showing you guys in two methods. That problem is nothing but log x by x. Okay, I wanted to show this problem to you guys, log x by x. Okay, what I'm going to do is I'm going to just pan into some fresh space here so that I can show you both the methods. Okay, so when I pan, I'm going to use a different color pen. Let us go with y is equal to log x divided by x. Now let us solve this initially using quotient rule. Okay, I'm going to write it as quotient rule QR. Okay, and for product rule I'm going to write it as PR. Essentially these are just my short forms. These are not the short forms that are given in the book. These are just my short forms. Okay, so you may not find these short forms in the book. Alright, so you may not find these short forms in the book. And now the next one is here, that is the quotient rule, product rule. Okay, I'll tell you how to solve it using both the method. First, let us deal with the quotient rule, d by dx of u by v, where this is nothing but v square v into du by dx, pardon my handwriting is very bad, minus u into dv by dx. Okay, so let us take u as log x and v as x, right? So my dy by dx will be nothing but x square in the denominator, that is v square v x into differentiation of log x. If you write u as log x, differentiation of log x, du by dx is nothing but 1 by x. Okay, so this multiplied by 1 by x, okay, minus u into u is nothing but log x, okay, into differentiation of x, essentially 1. Okay, so this will lead, can cancel this and cancel this, and I will get 1 by x square into 1 minus log x. Okay, dy by dx. Okay, 1 by x square, which x square I have removed common outside from both of them, and I have just written this as 1 minus log x. Is that fine? I hope it is fine, right? Now we are going to use the same formula here as product rule. Let me show you how interesting it is to use it in terms of product rule. Okay, let me extend this arm a little bit this side if possible. Let's see if I can extend this arm. Yeah, I can extend this arm here, and I'm going to show you how to do that. So I'm going to take 1 by x as one function and log x as another function. Okay, 1 by x is one function and log x is another function, and I'm going to differentiate dy by dx, okay, where my u is one function 1 by x and my v is another function log x. Okay, now for those of you who are just starting with differentiation, I will tell you the formula for 1 by x, how to solve the formula by 1 by x. This problem is problem within a problem, so there is no direct formula for 1 by x. What you have to do is you have to take it as x to the power of minus 1. Now this is in the form x to the power of n, and the solution is n into x to the power of n minus 1. Okay, so you get u is minus 1 into x to the power of minus 1 minus 1. So that is nothing but minus 1 into x to the power of minus 2 or minus 1 by x square. Okay, so this is how you solve du by dx. Okay, and v, you have a formula directly for that, dx, okay, so dv by dx is directly 1 by x, okay, is directly 1 by x. Right, now let me apply these formulas here and let me try to solve this problem where I have it is nothing but u into dv by dx plus v into du by dx. Okay, please note that initial days you might find using quotient rule in terms of product rule as slightly difficult, but when you have complex functions, I assure you, you will love it. You will just love it. Okay, so dy by dx is nothing but u. Now my u here is nothing but 1 by x, and dv by dx is, again I have already done that, it is 1 by x, okay, plus my v is nothing but log x, okay, log x, and my du by dx is nothing but minus 1 by x square. Okay, let me bracket everything. Okay, so that will give me x square. Okay, the x square becomes LCM. Here I have 1. This I'll bring it to this side, and okay, let me solve it. For those of you starting, it might be quite difficult to understand this, so I'll simplify this. I'll get 1 by x square. I will get this log, this 1 minus x square in front, and I'll get it as 1 by x square log x. Okay, and this will let me, when I take the LCM, I'll get it as x square 1 minus log x. Okay, this is essentially this formula. Okay, so there are, in conclusion, what I'd like to say is you can really avoid the quotient rule. You can actually avoid the quotient rule. Let me not write quotient rule, let me just write it as QR. Okay, you can just avoid quotient rule. Someone might ask if log x is in the denominator. Okay, you have something like x square by log x. Okay, in the future we will discuss something called as chain rule, and then what you can do is you can actually express this as x square into log x to the power minus 1 and solve this in terms of uv. Okay, in terms of product rule you can still solve this, even there are complex functions, let us say cos x, sine inverse x, and all those things. Okay, for now this is it. I hope you enjoyed. Please subscribe to my channel for more videos, and also please comment on what you want me to proceed with, and I will make sure I explain those stuff to you. I hope you enjoy mathematics. Have a nice day. Bye.